Welcome to the Explainer. Today, we're diving into a pretty radical idea. What if the best way to heal our bodies is to, well, stop them from trying quite so hard? We're going to zero in on a single enzyme that might just change how we treat everything from heart attacks to liver damage, all by learning how to get out of our own way. So let's just kick things off with a question that really gets to the heart of this whole breakthrough. Imagine this. What if, after something as traumatic as a heart attack, the body's own repair crew was actually preventing a full recovery? What if it was making things worse? So how on earth is that even possible? Well, to get it, we need to meet a very specific enzyme that's kind of living a double life inside our bodies. Its name is 15-PGDH, and it can be a huge help or a huge problem. Okay, so what exactly is 15-PGDH? You ready for the full name? It's 15-hydroxyprostaglandin dehydrogenase. Yeah, it's a mouthful, but what it does is actually pretty straightforward. It's the main enzyme that shuts down these things called prostaglandins, which are basically powerful little messenger molecules that manage inflammation and help organize tissue repair. You know, the easiest way to think about 15-PGDH is as the body's dedicated cleanup crew. So after an injury, prostaglandins rush to the scene to get the healing process started. Then, 15-PGDH is the team that shows up after them to break them down, basically telling the emergency response, all right, job's done, you can stand down now. Its whole purpose is to bring things back to normal. And get this cleanup crew is basically everywhere. It's all over our tissues, but we see it in super high levels wherever there's inflammation. And this is really key for cardiovascular disease. For instance, in a really dangerous condition like an abdominal aortic aneurysm, that's where the body's main artery gets weak and starts to bulge, we see 15-PGDH levels go through the roof as the body tries to get that inflammation under control. Okay, but here's where the plot thickens. What happens when this cleanup crew shows up at the wrong time or maybe works a little too well? This is where we run into this fascinating and kind of dangerous paradox in how we heal. This is the turning point. After a massive acute injury like a myocardial infarction, a heart attack, is this enzyme still on our side? Or has it suddenly switched teams and become the enemy? And this slide just lays it all out, right? You can see the two faces of this enzyme perfectly. On one side, in long-term chronic inflammation, it's a helpful break. It slows down a process that's getting out of control. But on the other side, after a sudden injury like a heart attack, it becomes a harmful barrier. It jumps in and breaks down these critical healing signals way too fast. And the result? It stops real tissue from regenerating and instead promotes permanent scarring, a nasty process called fibrosis. In this quote from the research, man, it just nails it. It says that 15-PGDH activity actually promotes cardiac fibrosis. It helps create the scar tissue. But when you get rid of it, the heart can actually recover. And after a heart attack, that scar tissue is the absolute last thing you want. It's stiff, it doesn't pump, and it's what ultimately leads to heart failure. Okay, so if we know this enzyme is the bad guy in this particular story, and it's blocking the heart from healing properly, the next question is a no-brainer, right? Can we stop it? Can we find a way to block the blocker and let the body's own repair crew do its job? And the answer appears to be a big, resounding yes. Scientists have developed this powerful little molecule called SW33291. Its entire job is to seek and destroy, well, not destroy, but to find and block the 15-PGDH enzyme. It basically puts that overeager cleanup crew on a coffee break. The whole strategy here is it's beautiful in its simplicity. So after a heart attack, the body sends in that healing molecule, PGE2. Normally, 15-PGDH would swoop in and get rid of it. But now, this new drug, SW33291, steps in and blocks the enzyme. That means those healing molecules get to stick around at the injury site for way longer, giving the heart muscle more time to actually regenerate and leading to way, way less scarring. And the results from early studies are just incredible. They did a study on aged mice that had heart failure, and treating them with this inhibitor, it led to a major improvement in their heart function. We're talking both systolic and diastolic function. In simple terms, their hearts were pumping blood out more forcefully and relaxing better between beats. The bottom line? The treated hearts just worked better. A lot better. But wait, it gets even bigger. This isn't just a story about heart attacks. The success here points to a brand new way of thinking about regenerative medicine, something we could potentially use all over the body. I mean, just look at this list. The potential here is staggering. In animal studies, blocking this one enzyme has shown benefits in everything from acute kidney injury and liver damage to fighting age-related muscle wasting and even helping recovery from a traumatic brain injury. It's like we found a master key for tissue repair. So what this is really telling us is that there might be a universal way to heal. By just stopping the body from breaking down its own repair signals too quickly, we can supercharge tissue regeneration. It's not about adding some fancy new ingredient. It's about turning up the volume on the healing music that's already playing.
And that leaves us with this one big, kind of mind-blowing thought. For so long, medicine has been about fighting a problem, attacking a bacteria, cutting out a tumor. But maybe, just maybe, the next great leap forward is less about fighting and more about just taking our foot off the brake and unleashing our body's own incredible natural power to heal itself.